So Ampere circular law we have discussed. So we all know the magnetic field due to solenoid, that is mu naught Ni, and toroid is mu naught Ni by 2 pi r. So I am not going to the expression of magnetic field, which you already know. We will discuss directly questions. So let us do this question number. It's a very easy question, 52. You can do it. So we have done, I think we have done the solenoid question also, right? We have done the solenoid question 52 and 53. So moving to the force between parallel current Ampere wires, we have done the last question was like, okay, so let us do question based on force between current carrying wires. So let us attempt this question number 56. So you do question number 56. Force formula we already know, F is equal to IL cross B. So using that we can solve this question number 56. So do this. Are you doing this question number 56? Coplanar means in the same plane, like in the XY plane. The coil is in XY plane. Same plane as the wire. So you got your answer as C. What is, so let us see. It says a square loop ABCD carrying a current I is placed near and coplanar with a long straight conductor XY carrying current I. The net force on the loop will be. So XY is a long conductor. So here magnetic field, if you talk about magnetic field at AB, like magnetic field at AB will be equal to mu naught I by 2 pi L by 2, and magnetic field at CD will be equal to mu naught I by 2 pi L plus L by 2. We have to see the distance. So, and so force is IL cross B. Magnetic field will be, what is the direction of magnetic field? Obviously, it will be inward. So, IL cross B, so direction of magnetic field is inward. So, force on AB, force on AB will be ILB, I into length, L into magnetic field, mu naught I by pi L. So obviously the, what is the direction of force? It will be towards left. On AB it will be towards left. And if you see force on CD, that should be, and the current should be small I, right? Here the current should be small I. This should be small I because we are taking that. And if on CD will be ILB, it means IL into mu naught I by 2 pi L into 3, and we will have 2. And what will be the direction of CD force? It will be towards right, right? It will be towards right. So net field we have to subtract. Net force will be equal to, we have to subtract. So it will be FAB minus FAB minus FCD. So we will take common mu naught I by mu naught I into small I L, and we will take that common, divided by pi. We will take that common, mu naught I small I L upon pi. So we will get it as 1 minus 1 by 3. So we will get 2 by 3. That. So your answer was correct. We are getting C. Got it? So this way we have to calculate the magnetic force on a current carrying wire in presence of magnetic field. So this is how question is asked in the NEET. Same is the question like 57, which I will give you in the assignment. Same type of question is this. Now we will move to the question based on torque on a current loop or magnetic dipole. So we know the formula for torque on a, the torque on a loop is given by that So we already know the formula. Torque is mu cross B. If there is a current carrying wire placed in a magnetic field, torque acting on the loop is mu cross B, right? Or M cross B. So where mu is the magnetic dipole moment and it is NIA cross B. So this is the basically formula for torque acting on a current carrying loop placed in a magnetic field, that we all know. So based on that, we are going to do questions first. So let us see question first. So do this question number 60. Do this question number 60. This is NEET 2015 question. So attempt this question. Are you doing this? Okay. So you got answer D. So it says a rectangular coil of length itna and width itna is having 50 turns of wire is suspended vertically in uniform magnetic field of strength. This the coil carries a current of 2 ampere if the plane of the coil if the plane of the coil is inclined at an angle of 30 degree with the direction of the field, the torque required to keep this. So we know that for equilibrium torque must be 0. So the plane of the coil is inclined at 30 degree, then the torque required to keep so there is a coil. The coil carries a current of this if the plane of the coil is inclined at angle theta with the direction of the field. The torque required to the coil in stable equilibrium. If the plane of the coil is inclined at so if the plane of the coil is inclined at an angle 30 degree with the direction of the field, so suppose there is a magnetic field, so plane of the coil is making an angle 30 degree with the direction of the field. So what will happen here is so basically we have to find the torque due to magnetic field. So to keep this coil is in equilibrium, we have to apply equal and opposite torque on the coil. So what will be torque? We know that torque is NIA cross B. So torque is NIA cross B. So what is the area vector, direction of area vector? So area vector is always perpendicular to the plane. So the angle between magnetic field and area vector will be 60 degrees. So the torque will be, magnitude of torque will be NIAB sine 60 degree. So N is number of turns, that is 50. Current flowing in the wire is 2 ampere. Magnetic field is 0.2 and sine 60 we know that root 3 by 2. So these are the values, and putting that we'll get it as this is 100 into root 3 divided by 10. So it should be 10 root 3, right? So 10 root 3 is like it will be 1.73 something. So it will be 17 point something. Let us check again. Oh, sorry, we have to find the area also. We haven't written the area. We have to multiply by area also. So it will be into area. So area is like 0.12 into 0.1. So we have to multiply by 12 into 10 to the power minus 3. So we will get as 1.2 into root 3. Sorry, 0.12 into root 3. This will be equal to 0.12 into root 3. So multiply 0.12 into root 3. How much we get? 0.12 into 1.732. So we will get 0.20 something, right? So we will get it 0.207 Newton meter. Got it? Have you applied the same method? So this is how we should solve the question, and we can get it right. So moving to the next question. Now the important part is, so this is how we should, torque and all, and there is also some question, maybe potential energy and all, that is in the next. Okay. So now we are going to, there is also some question related to potential energy, like potential energy of a dipole minus P dot T. So that will maybe come in the next chapter. So we will study that in the next chapter. Questions are there. So before that, we will do questions based on conversion of the moving coil galvanometer. Very important. And so let us first discuss what it is. Very easy and very important. So first we will discuss moving coil galvanometer and their conversion. Moving coil, I am not going to detail. Moving coil galvanometer, MCG. So in this, what happens generally is there are three things. First, we are study about what is moving coil galvanometer and what are the things there. Then we will study conversion of moving coil galvanometer. There can be two type of conversion. It can be converted into ammeter, it can be converted into voltmeter. So these are two aspects of the chapter which we are going to study. First, we will study about structure and its formula, what it is generally used. So if you see about the general idea of moving coil galvanometer, so here what happens is generally we are using some terms like the coil is like that. In this, actually, we have some coil suspended with some mechanism like moving. What moving coil galvanometer basically do is we have some calibrated kind of coil, and this is connected with some kind of a spring. So what happens is when it moves, it is connected with a coil basically. So when this coil moves, what happens? Torque is developed, or restoring torque develops within the uh, the arrangement of the coil. So the deflection is directly proportional to torque acting on the uh, coil, right? So we will have general idea basically, like we can say that suppose uh, basically the deflection will be directly proportional to theta, right? Or you can say the torque acting is directly proportional to the theta, or you can say it is k theta. And we know that in a coil the torque acting is equal to NIAB. So from here you can calculate different things, k theta, where k is a constant, basically spring constant or something constant, that will be given. So from here we will define two terms. One will be current sensitivity, IS, we are going to define, which is basically a deflection per unit current. How we will define sensitivity? How much is the deflection per unit current? So from here you will get the formula for current sensitivity, which will be equal to NAB upon K. Similarly, we defined voltage sensitivity, that is deflection per unit volt, and that is also we can write like V is equal to IR. So from here you can write, we know that V is equal to IR. So like this, so 1 by R into theta upon I, NAB upon K. Like that we will have formula NAKB by R. So in voltage sensitivity, just divide the current sensitivity by resistance, you can get the voltage sensitivity. Got my point? So these two formula basically will be used in the uh, working part of the galvanometer. Have you understood this? Any doubt? So basically you can see the different parameters on which the current sensitivity depends. If you see here, the current sensitivity depends upon different parameters, like it depends upon area, it depends upon magnetic field, it depends upon number of turns, and voltage sensitivity also depends upon number of turns, area, and magnetic field. Have you got it? So we are not going into detail, going into construction and working and all. I will directly give you the formula which are going to be used in the numerical. So have you understood this part, voltage sensitivity and current sensitivity formula? And we will see how to use this in the questions. You know this formula? Have you understood it? How to remember? You don't need to remember. You can directly use this formula. All right. So let us do the questions. based on sensitivity and all. So let us do this question number 72. First do this question number 72. NEET 2018 question. So you got C. Current sensitivity of a moving coil galvanometer is this, and its voltage sensitivity is this. Then resistance of the galvanometer. So we have to find the resistance, right? So we have learned that current sensitivity IS is basically uh, inversely proportional to current, and we know that voltage sensitivity is inversely proportional to resistance, right? We know that. So if we divide both, like current sensitivity by voltage sensitivity, we will get it as 1 by I divided by 1 by R, right? So 1 by I 1 by R, so you will get 1 by IR, right? So we have to find the resistance. sorry, voltage sensitivity is theta upon V, that is 1 by IR, right? So voltage sensitivity is proportional to IR, not only IR also. So you will divide it like this. So we will get it as IR, right? So you will get it as IR upon I. So you'll get it as R. So resistance will be basically equal to current sensitivity by voltage sensitivity. And what is current sensitivity? 5 division per milliampere. So it will be 5 per milliampere 10 to the power minus 3 divided by voltage sensitivity is 20 division per volt. So we'll get it as 5 upon 2000, right? So R is 5 upon 2000. Sorry, 5000 upon 20. R will be equal to, not that, R will be equal to 5000 upon 20. 5000 upon 20. So what will be that? It will be 250, right? It will be 250 ohm. So the correct option is C. Understood it? So this is how, this is NEET 2018 question. So this is how we should go ahead for questions based on voltage and current sensitivity. Don't remember much formulas, only you have to remember that current sensitivity is inversely proportional to current, voltage sensitivity is inversely proportional to current and resistance. That's all. Got it? All right. So this was question so this was the question based on, basic question based on moving coil galvanometer. Now we will do some question based on convergence. That is very important. Basically questions are asked based on convergence, and sometimes you may get term full scale deflection means maximum deflection. So we will see questions. So now I'm going to show you the conversion. That is very important and very easy and very important. Every time questions are asked on convergence. So that is the most important part of MCG. So basically we will see the convergence of convergence. In convergence, what we do? We convert moving coil galvanometer MCG can be converted into two things. It can be converted into ammeter and it can be converted into voltmeter. So how we will do that? Basically, we symbolize a galvanometer like, suppose we have a galvanometer G. So To convert it into a ammeter, what we do? We do nothing, just we shunt it. What we do it, just we connect a shunt resistance with it. Suppose this resistance is S. So we are doing shunting. To convert a moving galvanometer to ammeter, you just have to remember, you have to shunt the galvanometer through a small resistance. So this is now converted to ammeter. Suppose we have a current like this. Total current is I. Sometimes the current through the galvanometer, suppose Ig. So here current will be I minus Ig. So we can write the formula like this: Ig into G will be equal to I minus Ig into S. So Ig is basically full scale deflection of the current of the galvanometer that will be given generally. So from here you can calculate the required thing, whatever required, you can calculate it from the given formula. So this is the basic formula which we are going to use in conversion of moving coil galvanometer into ammeter. Now coming to the voltmeter part, what we do? We generally we connect the galvanometer in series with a large resistance. Suppose we have a resistance R. So what we do? We connect the galvanometer with a high resistance. This is very high resistance in series. High resistance. So we connect the galvanometer with a high resistance in series, and this is basically converted into voltmeter. This configuration is known as voltmeter. So suppose the current through the galvanometer is Ig. So and total potential is this. So you can write V equal to Ig into R plus G, right? So this will be formula used to convert a galvanometer into voltmeter. So this is the basic idea, and we will do the questions. We will get more clarification. So have you got it? How we converted galvanometer to ammeter and galvanometer to voltmeter? Very easy. For ammeter, do shunting. For voltmeter, just connect a resistance in series. So have you understood this? Should we move to the questions? Rifat? All right. So let us do the questions. So first, do this question number 73. It is asked in NEET 2014. So attempt the question number 73. Yes, we have to convert the percentage. So you got C. Okay. This is in an ammeter. So actually, a galvanometer is converted into ammeter. So what we do? We do shunting like this. So this is S, and suppose total current is I. So in an ammeter, 0.2% of main current passes through the galvanometer. So here what pass? Like 0.002 I, right? 2%. And if the resistance of the galvanometer is G, then resistance of the ammeter. So we have to find resistance of the ammeter, right? Total this resistance we have to find. So we have to calculate S for that. So we can say that 0.002 I into G will be equal to I 1 minus 0.002 into S. So from here we can calculate S. S will be equal to basically 0.002 into G by 1 minus 0.002. It means 0.998, right? 0.998. So we will get S as G upon 499. So this is we are getting the shunt resistance. Now we have to find the total resistance, right? So to find the total resistance of the ammeter, what we will do? Total resistance of the ammeter will be equal to GS by G plus S. So G into what is S? G upon 499. This is we got shunt resistance upon G plus G upon 499. So we will get it as 49 will cancel out. So G upon 500, right? G upon 500 is the value of resistance. So the correct answer is C. Got it? So this is how we should proceed. Understood? Okay. So this is how we should work upon the questions based on conversion of a galvanometer into ammeter. Now we will see the questions based on conversion of a ammeter into voltmeter. So do question number 76. Do question number 76. Are you doing it? You got 700. So let us check. It says a galvanometer has a coil of resistance. A galvanometer has a coil of resistance 100 ohm and gives a full scale deflection of for 30 milliampere current. If it is worked as a galvan voltmeter of 30 voltage range, 30 volt range, the resistance required to be added will be. So it says that we have a galvanometer has a coil of, so suppose we have a galvanometer and we have converted it into a voltmeter. So we have to connect it to a series. Suppose this resistance R. So we have to find this resistance R, and its resistance G is given as 100 ohm. This is given. Now it says that in the question we have given the voltmeter has to work 30 voltage range, means this potential difference should be equal to 30 volt. Voltmeter reading should be 30 volt for full scale deflection. So basically Ig, this current Ig is given as 30 milliampere, right? So let us see. We have to calculate the resistance. So we know that voltage V is equal to Ig into R plus G, and this voltage is given as 30 volt and Ig is given as 30 milliampere. So 30 into 10 to the power minus 3. R we have to calculate. G is given 100. So from here we can calculate 1000 equal to R plus 100. So from here we will get R equal to 900 ohm. Have you understood it? So this is how we should calculate. So where you have gone wrong? Okay. So okay, all right. Moving to the next question. So let us do one more question. Do question number 78. We can do that. Do question number 78. We got it as B. The galvanometer resistance 50 ohm is connected to a battery of 3 volt along with resistance of this in series. The full slit deflection of 30 division is obtained in the galvanometer. In order to reduce the deflection to 20 divisions, the resistance in series should be let us see. Says that a galvanometer of resistance is connected to a battery of, suppose we have a galvanometer and it is connected to a battery of 3 volt along with a resistance of its series. So we have resistance 2950 in series and G is given as 50 ohm and it is connected to a battery of 3 volt. A full scale deflection of 30 divisions is obtained in the galvanometer. So when potential difference is like it measures 33 volt, the current Ig is given as 30 divisions. Okay. In order to reduce the deflection to 20 divisions, so now to reduce it to 20, the resistance in series should be. So suppose this resistance is R. So we have to calculate that R. So from there, what we can write, so actually full scale deflection is directly proportional to current. So what we can say is like 30 equal to 3 upon 2950 plus 30 division direct current is equal to 30 is equal to 3 by 295 plus 3 along with the resistance of this. So the full scale deflection of 30 division is obtained in the galvanometer in order to, so directly we can write it like this also, 30 into 2950 plus 50, that will be equal to 20 into 20 into R plus 50, right? So from here we can calculate the R. Basically potential will be constant, current is variable, current is directly proportional to number of divisions kind of thing. So from here you can write 3 into 3000, 2950 means 3000 and that is equal to 2 into R plus 50. So from here you will get we will get 1500 into 3, 1500 into 3 is equal to R plus 50. So from here we will get R is equal to 4500 minus 50. It means 4450. 4450, right? So the correct answer is B. Your answer was right. So only what we have to do is, there is no use of this 3 volt. Just you have to write I1 R1 is equal to I2 R2 and you will get the answer. Have you got it? All right. So this chapter almost comes to end. Let us do some more questions and then we will move in the next class. We will move to the next chapter. So the voltage to convert to this question number 74. Attempt question number 74. All right. So it says a millivoltmeter of 25 millivolt range is to be converted into an ammeter of 25 ampere range. Okay. The value in ohm of necessary shunt will be. So we have a voltmeter. Suppose we have a voltmeter and its range is given as 25 millivolt. and it is to be converted into an ammeter of 25 ampere range. The value of necessary shunt. So to convert a voltmeter or to convert a galvanometer into ammeter, what we do? We shunt a resistance. It is given in the question. Necessary shunt. So suppose this shunt resistance is S and ammeter of 25 ampere range. So in that case, this current is given as 25 ampere, right? So now what you can write? Suppose this shunt current is IS. So what you can write? IS into S is equal to 25 minus IS into or you can directly write IS into S will be equal to, suppose resistance of the voltmeter is not given. So what you can do is you can also write it like this. IS into S will be equal to this voltage 25 into 10 to the power minus 3. Actually this potential across this and this will be equal. So we have to calculate the IS, right? We have to calculate S. But here what you can do is, we know that resistance of a voltmeter is very high. We know that it has high resistance, very high, almost infinity. So here current will be equal to almost zero. Current passing through a voltmeter is almost zero. So all the current will, this current will pass through this. So IS you have to take 25 ampere. IS you can take 25 ampere. So 25 into S will be equal to 25 into 10 to the power minus 3. So from here what you will get? S will be equal to 10 to the power minus 3. It means 0.001. So here this trick you have to apply. Otherwise you cannot solve the question. If you will go by general method, you cannot solve. So you have to apply some mind here. You have to apply some concept, and this is very important here. Understood it? All right. So the correct answer is A. So this is all for today. I am ending here today's class, and in the next class we will discuss the next chapter, magnetism and matter. So for some remaining questions, I will give you the assignment. You can solve, go to the portal and solve the question. If you have any doubt, you can ask. Otherwise, we can log off. Thank you for today.